Now, moving on to standing waves in different scenarios. So first, if we take an example of a windpipe, जिसका one end is open and the other end is closed, so we will observe the following patterns which would depend on the wavelength of the sound wave which is used to produce these waves. So as you can see in the diagram, first harmonic wave key length would be L is equals to half lambda 1 by 4 lambda 1. Second harmonic wave key length would be L is equal to 3 by 4 lambda 2. And these harmonics would show the motion of the air in the tube. And one thing you need to note here is that antinodes will always be formed at the open ends. And this shows that the air can move back and forth at the open end but not at the closed end because there are nodes at the closed end. So now if we take an example of a pipe जिसके both ends are open, then antinodes would be formed at both ends. And this shows that the air can move back and forth at both ends. And in this case, the first harmonic wave would be half lambda 1, and the second harmonic wave would be lambda 2, and so on. Now, if we take an example of a tube which is filled with water, so जो air column की length है, it could be varied by draining water from that tube. And example में, we will be using a tuning fork which would resonate the air column at specific wavelengths. So as you can see in the diagram below, there will always be nodes at the closed end and antinodes at the open ends of the tube. In this case, the first harmonic wavelength would be lambda by 4, second harmonic wavelength would be 3 lambda by 4, and the third harmonic wavelength would be 5 lambda by 4.